5 Minute Friday number 6, and last week we looked at the digital readout on the lathe. This week we're going to be looking at the same digital readout, the Acu-Rite VUE, on a milling machine, and we're going to be drilling some holes on a PCD and in a linear array. Okay, so the basic plan is on this piece of scrap, just on one side do a PCD, on the other side do some kind of linear array. Now I'm not going to drill it all the way through. What I'm going to do is just spot it, and I've been reading about the difference between spotting drills and centre drills, and there was a bit of an argument on Reddit this week, as there always is on a forum, and the general consensus of the forum was that the spot drill is much thicker, so it's more rigid and better in a milling machine, whereas you'd reserve the centre drill for use on a lathe. And there was different people with different opinions, but the general consensus was that the spotting drill, spot chamfer, is a better tool for it, so that's what I'll be using. So in order to hold that, we'll be using the collet system now. Collet spotters amongst you will notice the difference between the ISO 40 taper that we've been using on the CNC and the R8. And this is an R8 taper with a ER40 collet. I'll just show you the loading of the collet. There's a two-part process. One is to detach this outer ring, make sure it's free of any debris. Second is to put this in at a slight angle and then screw it into the collet itself. We're just going to check that it hasn't detached there in any way. Next, put the tool in. And on manual, we're not going to worry about tool height offsets. And then when that's in the machine, we'll use the spanner to rack it up. The second bit we're going to do a bit of edge finding before we start, and we're going to use this, a wiggler. Now, I'm not going to go through this in any real detail this week. We will do that in a separate video, and we'll look at different techniques for edge finding and using a 3D touch sensor as well. So once we've had the wiggler kick out, what we'll need to do is take off half the diameter. Now it was 6.35mm in diameter, so we can actually use the calculator function here just to show you how that works. Divide by 2, 3.175. So in the x-axis, we're just going to go to set and to negative 3.175. And we'll do the same in the y-axis, then we'll be ready to go, and we'll start off by doing a linear array. Okay, so now we've done the edge finding, what we're going to do is use the linear array calculator, and we can choose between either an array of holes or a frame. We're going to choose array, and we're going to have the first hole position as 10. And the second is negative 10. Holes per row, we're going to have 5. I'll have a hole spacing of 2. We can adjust that array by a particular angle. We're not going to. And Z is in case you've got an encoder on the Z axis. And again, you'd hit teach to set the depth. We're not going to bother with that. We're going to use 3 rows at a row spacing of 2. So we'll navigate to the first position, and we're given this visual guide here. So as we approach the centre point, or our existing point here, it will give us the position to drill. And we'll do the same in the y-axis. So what we'll do now is change the tool and start drilling some holes. So now the hard work's been done. We've found our edges, set the datums, and created the linear array on the DRO. So all that's left now to do is drill the hole, hit next, navigate to the next position using the visual guide, and then the linear array will be created. So I've noticed that these holes are going to be a bit too close together, so it's just a case of hitting the linear array button, navigating back down, choosing 5 in the hole spacing, and the row spacing 5, and it's going to automatically update our settings. So now we have the linear array, we're going to use a PCD. So hit the PCD calculator, much the same principle, except we can choose between full, circle and segment. We can choose to have 6 holes, and the center point, rather than move to a point and then enter it, we're going to go to an arbitrary location, hit teach, and then it will now define the coordinates based on these 2 positions. We're going to go for a radius of 10 mil. And the start angle is going to be 0, and we'll advance in an anti-clockwise direction as with all polar coordinates. And we don't have to worry about the z-axis because we only have 2 encoders. So that was the Acu-Rite VUE DRO for the milling machine. Next week we're going to do some HSM works and CNC programming. So if you like these videos, remember to like and subscribe, and if you want any particular kind of topics covered, drop a comment in the section below.